Hello, it's Scott Manley here. You might have read news stories that are saying that China are planning to launch an artificial moon into orbit, able to illuminate cities in China by 2020. Now, the article kind of extrapolates this to, well, rather extreme conclusions. They are talking about a satellite in a 500-kilometer orbit, and yet simultaneously the article is saying that, hey, if you could use this to illuminate a city, you could save, $174 million per year. Well, the problem is with a 500-kilometer orbit, you're not going to be able to continuously illuminate a single city. You're going to have to wait for the satellite to be in the right place at the right time. It might only be a few minutes per night when the orbital planes are aligned, and when it's not aligned, it might not be in the right place for months at a time. Now, it does sound to me that this is something a lot like an old Russian project called Zenmaya, I believe. And I probably said that wrong, but we'll work on my Russian pronunciation. They used a 5-meter mirror. The 5-meter mirror was actually mounted onto a Progress supply ship that had visited Mir in 1992. It dropped off its supplies, and after it detached and was going to burn up in the atmosphere, they used it as a platform to perform this experiment. They unfolded this mirror, which was originally developed as a solar sail, but they couldn't get funding to develop it bigger. Then they flew this and they used it to reflect sunlight onto Europe, and unfortunately it was cloudy, so not many people actually saw it. But the idea is solid. Now, with a flat reflector, the best you can do is reflect the sun into a half-degree cone. So from 500 kilometers up, it would create a spot of light about 5 kilometers across, right? So you would have this 5-kilometer spot of light. Also, because the spacecraft was moving at 7+ kilometers per second, that spot was zipping across the surface. So this wasn't really providing illumination so you could go about your everyday life at night. No, it was like a giant satellite flare if you happen to be looking at the right place at the right time and happen to be under this 5-kilometer track. The Russian scientists continued with this idea, and they built a follow-up mission which was going to have a 20-meter mirror. Unfortunately, that mirror failed to unfold and the project is essentially dead. So it sounds to me like Chinese are taking this idea and they're going to do further experiments with them. Now, I don't expect them to actually, again, illuminate for any length of time. They're probably going to set it up so they can illuminate for a few minutes at a time. It's probably going to be 20+ meter mirror. It will have to track with the sun to keep the spot focused on a specific area. And yeah, if you do the math, it works out that 20+ meter mirror can be focused onto an area, giving you about 10 times the brightness of the moon relatively easily. Now, if you wanted to then take this newspaper's concept of illuminating cities, you would in fact need to have the satellite way further out so it could hang over a specific area and continuously illuminate it. So geostationary orbit is an obvious choice. Now, geostationary orbit is about 36,000 kilometers away, and again, because of the laws of physics, you're going to be reflecting a half-degree cone of light, which works out to be about 360 kilometers diameter at the surface. So you could illuminate much larger areas of a province. To get illumination equivalent to the moon would be about a 600-meter reflector if it was only reflecting exactly onto that area. So if they want something 10 times the size of the moon, you're talking 1.5 to 2 kilometers. And that would indeed be able to continuously supply illumination for almost all the year. There would be times around the equinoxes where the Earth's shadow would get in the way. But there's another problem that they would need to deal with to try and make this work, because as you're reflecting that amount of light, you're experiencing radiation pressure from the sun. Now, radiation pressure from solar illumination is about 4.5 micropascals, which means about 4.5 micronewtons per square meter. So for a 1 kilometer square area, you're talking about 4.5 newtons. It's not much, but it's being applied continuously. So not only is this thing having to very carefully illuminate and keep its angle correct on this small area of the Earth, it also has to fly so that it maintains the orbit, because if it just follows that track, it will eventually cause its orbit to change shape, it'll drop out of geosynchronous, and it'll no longer be able to illuminate that area. Also, yeah, it does have issues. If the tracking isn't quite right, it could, illuminate neighboring areas. And, who can imagine the degree of international incident that would happen if you annoyed all those astronomers in neighboring countries? Now, it couldn't be turned into a weapon. Despite what science fiction, low-quality sci-fi likes to say, you can't actually use a single mirror to reflect the sun into a beam narrower than half a degree. So you actually need a very wide mirror, relative to the surface. At 36,000 kilometers out, it would have to be huge to be viable. Of course, if you were close to other geostationary satellites, maybe it could zap those, but there are easier ways if you want to build an anti-satellite weapon. Now, if you just want to create something that is like an artificial moon in low orbit, you can just use a balloon, similar to the Project Echo, where they were trying to bounce communication signals off metallized balloons in low Earth orbit. The moon is actually very, very dark. Its albedo is about 12%, which means it only reflects about 12% of the light. Fun fact, you can actually do this experiment where you take a picture of the moon using fixed camera settings, and then using exactly the same camera settings, you can take a picture of, say, a road during the middle of the day, and you'll find out that the road surface is roughly the same darkness as the moon, same albedo. So obviously your balloon would be much whiter, washed in the whitest of white washing powder that you can find. And yeah, it would have to be about 1 kilometer across to be roughly the same size as the moon in the sky, and that would give it about 10 times the illumination because its albedo would be about 10 times higher. So yeah, please don't do this because you will have the wrath and ire of astronomers to deal with. And who knows what those astronomers can do when they get really angry. I'm Scott Manley. Fly safe.